told me about was a technology that I'm fascinated with, homomorphic encryption.
To your comment about data in use, in 2018, there were two famous security breaches, one called Spectre and one called Meltdown, that allowed bad actors, were they on your computer, to peek across memory units and see data in its clear text format after it had been encrypted. And this kind of got folks' attention. Now, in the 70s, a team of researchers found a very weird encryption technique by which, let's say I had the number 10 and I encrypted it with my key. The key is Saskatchewan. And now I get this encrypted data that looks kind of like a plate of spaghetti. And I hand it over to you, and you go ahead and add 10 to it, let's say. And then you hand it back to me. I take my key and I unlock it. And lo and behold, what I get in the decrypted data is the number 20. And it sounds like that's black magic, but it's a mathematical property called homomorphism, that I can take information from one system, convert it to another, operate on it, and then when I take it back to the original system, the decrypted data winds up being the result of the operation. One of the negative sides of encrypting data with this type of technique is it becomes millions of times larger. So my funky example where I had the number 10, which would only take a handful of bytes in data. If I went and took that and made it homomorphic encryption, the encrypted data would be like a megabyte. And I would take it over. And so you can imagine the operations being done are going to take a million times slower and so forth. So that was a limitation. Along the way, 5 other techniques were discovered besides homomorphic encryption. Some of these techniques were truly changing because they didn't suffer the gross bloat and slowdown. So some of the ones that came out: trusted execution environments, secure multi-party computation, zero knowledge proofs, federated learning, differential privacy, private set intersection. If you're interested in any of those, there's some terrific papers out there diving into them. The other interesting thing that came about from this is since 2009, when there was a seminal paper written by a gentleman by the name of Craig Gentry. Since Craig Gentry's publication, several companies have been formed using some of the different techniques, what we call privacy-preserving computation techniques. These don't have that million times slowdown. They've been dramatically enhanced. If the bad actors that were exploiting Spectre and Meltdown were on your system, when they look over the proverbial back fence into adjacent memory and look at what's going on, that data is all still encrypted. Does that make sense?
It does. So if I'm going to play this back to you, so we have a series of assumptions that our customers have to make if they're being rational, which is that I'm either compromised today or I will be. So in the true fashion of innovation around technology, we're seeing a lot of effort to produce technologies that make it similarly secure in order to get to a less expensive approach. And so are you implying to me, Mark, that we're tracking some of those developments and that might have some opinions if our customers have this problem?
Yes, indeed. No, we're tracking this very closely.